It is the exceptionality of each of these conditions and their combination that turns my eye, my sight, toward the possibility of a guided creation. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah wa barakatuh. Chapter 2, Section 4, looking at the natural argument. Here I'm giving another example of natural argument, which is the unique living conditions. So after having discussed the exceptionality of life, I now discuss the exceptional conditions that allows this life to strive. So indeed, the earth plays the role of a unique type of cradle. I mentioned earlier that life, as we know it, requires energy from the sun. But more importantly, life requires liquid water in sufficient quantity to enable the necessary chemistry of life. A planet too small would not have enough atmosphere to keep its water in the liquid phase. Like the moon, for example, does not have enough gravitational pull to keep an atmosphere. Without atmosphere, the rays from the sun literally ionize the ground and whatever is around. So if you have liquid water on the moon, it will get ionized, vaporized, and kicked out in space. So you need a planet that is big enough to have enough gravitational pull to keep an atmosphere to protect liquid water from the sun rays. So a planet too small would not have enough atmosphere. Indeed, water would simply evaporate in thin atmosphere, like it's the case for the moon. A planet without an active core would not allow the degazing of the mantle, nor allow accumulation of the degazed water at the surface. So we believe when the solar system formed, you have like meteorites that aggregated one against each other. Water is present within these meteorites. Like we know, we can find ice crystals within meteorites. So you can imagine all these meteorites coming together, warming up, melting. Whenever these rocks melt, they let the water go. They evaporate. They degas. That gas then can accumulate and create an atmosphere around the newly formed planet. So a planet without an active core would not allow the degazing of the mantle, nor allow accumulation of the degazed water at the surface in a liquid form. Then, without a protective magnetic field provided by the active core, the surface water would just get ionized and blown away by solar wind, as it is the case for Mars. Mars is not that active anymore. It does not have that protection, magnetic field protection around it. So the rays just go through the atmosphere, ionize the ground, and vaporize whatever liquid water you may have. Similarly, a planet that is too close to the sun, like Mercury, or too far away, like Pluto, would see its surface water either being evaporated because it's too hot, or frozen because it's too cold. The rotation of the Earth, like the alternance of day and night, its atmosphere, its active core, its distance from the sun, the size of its warm body, its activity, all of these gives the Earth an almost constant temperature over the years. It's like plus minus 40 Celsius degree. From winter to summer, that variation can be considered negligible compared to the few thousand degrees from the sun's surface to the almost absolute zero of space. So to have such a small variations within seasons, from year to year, like plus minus 40 degrees at max, that variation can be seen as small, really small, compared to the heat of the surface of the sun and the coldness of space. Furthermore, this almost constant temperature ideally sits within the tiny range where water is liquid, gas, and solid. For comparison, let us represent temperature on a ruler with absolute zero on one end of the ruler and the sun's surface near the 5.8 kilometer mark, corresponding to 5,800 degree Kelvin. We are here talking about a variation, so that's the scale. So that's the scale, from 0 to 5.8 kilometers. That's the ruler, the length of the ruler. The variation we're talking about, plus minus 40 degrees, then represent within that scale plus minus 4 centimeters in that close to 6, in that about 6 kilometer long ruler. And these variation of plus minus 4 centimeters ideally sits within a 10 centimeter wide range where water is found in a liquid state, corresponding to the 100 degree range between freezing and the boiling point of water, from 0 to 100 Celsius. So outside of this 10 centimeter range, water is either frozen in the bottom of the scale and thus too stiff to facilitate any chemical reactions, or vaporized on the upper side of the scale, and thus not dense enough to enable chemical reactions that are required for life. So to imagine the temperature, just the temperature as a scale, as a physical scale, tells you how specific the conditions on Earth are, how exceptional they are. So the temperature on Earth allows for most of this surface water to be kept in its liquid phase for a period of time that are long enough to allow life and its development, to allow civilization to develop. That's quite amazing in itself. Just looking at the temperature on Earth is already quite amazing. Again, I want to point that these amazing facts are not proof that God exists, but that can be taken as evidence to support a theist conception of the world. To appreciate how exceptional Earth is, I also like to follow the scientific search for exoplanets, like other planets within the universe, and more specifically the ones that are similar to the Earth, because we believe that if a planet is similar to the Earth somewhere else, maybe life can develop in that planet also. So despite the literally astronomical effort of researchers to scrutinize the universe, the number of planets whose conditions are potentially similar to the Earth is confined to a few thousands. So when I wrote the book a few years ago, it was about a few thousands. That numbers obviously increase, but that numbers relies on so many approximations and assumptions. So at the time, it was 2020, there were about 4,000 candidates. So in this search of exoplanets, you have to understand the way you look for exoplanets is through spectroscopic means. You're looking at spectrum, light from outer space. So you don't see the planet directly, it's too small. You see the light that might be reflected by the planet. And to understand what this planet is made out of, you have to analyze the spectrum. And you can guess which molecule might be present. You can calculate how far they are from their sun. You can estimate the temperature depending on their size. You might estimate the activity. But these are, again, estimations. And for example, one of if you look at numbers from the NASA, these were numbers from 2020. So they had about 4,000 candidates, exoplanets, like Earth planets out in space. The NASA reported, quote, K2-18b is the only exoplanet known to have both water and temperatures that could support life, so similar to the Earth. Unfortunately, given the high level of activity of its red dwarf star, K2-18b may be more hostile to life than Earth, and it is likely to be exposed to higher energy radiations. So in other words, to this day, We don't know about any other planets that have similar environment and conditions like Earth. So we still, scientifically speaking, don't know if there's life out there in space. It's not straightforward. It's good to search. You should search for that, but it's not straightforward. It is based on modeling, on indirect evidences again. So this number of exoplanets will certainly increase with the development of new spectroscopic techniques. However, as the closest of these planets is located light years, literally, away from Earth, their confirmation is solely based on indirect observations and theoretical models. So far, the latest space exploration reinforced the idea that Earth and the environment within Earth is unique. Our solar system is located in a very particular branch of our galaxy that is not subject to devastating supernova explosions. So that zone within the galaxy is called the Goldilocks zone. There's no major disturbances. Like in other parts of the galaxy, things get destroyed commonly. The Earth has a magnetic field that protects humans, animals, and plants from life-threatening solar winds, solar radiations, and has a composition that is neither harmful, like by an excess of chemical component, unfit, like acids, sulfur compounds, oxidants, nor sterile by lack of element necessary for life, such as carbon, nitrogen, oxygen, hydrogen, iron, magnesium, etc. So it is the combination of all these necessary conditions that enables life and preserves it, which shows the uniqueness of Earth. It is as if Earth was specifically designed for the development of life. I therefore stand close to those who argue for the fine-tuning of the universe, in the sense that this extreme degree of precision required, which allows the development of life as we know it, that makes me marvel. I therefore stand close to those who argue for the fine-tuning of the universe. The fine-tuning of the universe, that argument highlights that tiny variations within the constant of the world would engender its collapse. It means that things seems to be so well structured that it cannot allow for much variations. To give a metaphor, for example, if you build a skyscraper, sure, it must be precise. You must put the foundations properly. But whether the brick is maybe half a millimeter to the right or to the left, it won't change much. It still holds. In the universe, it's not enough. The precision that it requires of this constant within the mathematical formula that I use to describe the world, these constants are so precise, so specific. They must be so specific, otherwise it falls apart. They must be so specific that specificity tells you that it must have been created for purpose. That's one way how to explain. Again, it's not a proof, irrefutable proof that God exists, but it's an evidence you can use to support a theist view of the world. So I therefore stand close to those who argue for the fine-tuning of the universe, in the sense that it is the extreme degree of precision required in the laws of nature, which allows the development of life as we know it, that makes me marvel. It is the exceptionality of each of these conditions and their combination that turns my eye, my sight, toward the possibility of a guided creation instead of a world that has emerged from randomness and left to itself. جزاك الله خيرا. والسلام عليكم ورحمة الله وبركاته.